Welcome back. Today, we're going to learn how to use locking in JPA, a key concept to handle concurrent data access safely and prevent unexpected issues in your application. Alright. In our employee service class, the update employee method first calls find by employee ID for update, which is responsible for locking the employee record. After that, it calls another method to actually perform the update. But in this video, we'll focus only on understanding the different types of locking in JPA, and we'll implement just the find by employee ID for update method. In the next video, we'll see how to perform the actual update operation. After that, we'll revisit all JPA locking types and walk through a complete code demo, because the update part is essential for that. Look at my screen. When we used JDBC queries, we applied the forUpdate keyword to lock records. But now, the question is, how do we handle locking in JPA? Let's find out. First, we're going to use a JPQL query to fetch data and apply locking to ensure safe concurrent access. Alright, let's start by writing our JPQL query to fetch an employee record based on the employee ID. Okay, here's the thing. JPQL doesn't give us a built-in way to add locking directly inside the query itself. That means we can't just write something like forUpdate in JPQL like we do in SQL. But don't worry. JPA provides us with special methods to enable locking when we run the query. This way, we can safely lock the database rows while fetching them, preventing conflicts when multiple users try to update the same data at the same time. Now, let's call the createQuery method of the entity manager, where we pass in our JPQL query string along with the expected return type, in this case, the employee class. Next, set the value for the employee ID parameter to tell the query which employee's data to fetch. Okay. Now here's something important. The entity manager gives us a handy method called setLockMode to control locking. This method lets us tell JPA exactly which type of lock we want to apply on the data when running the query. Alright, here's an important point. The setLockMode method accepts a parameter of type lockModeType, which is an enum in JPA. Now, what's an enum? It's like a predefined list of lock options that JPA gives us to choose from. Each lock mode type defines a specific way to lock the database rows, such as optimistic or pessimistic locking, depending on how strict you want the lock to be. Now let's talk about lockModeType.read. Technically, it works the same as optimistic locking, so you can think of it as just another name for it. But here's the key point. For modern applications, it's better to use optimistic directly. LockModeType.write is basically synonymous with optimistic_force_increment. They both work the same way. But for new applications, it's recommended to use optimistic_force_increment directly, because it clearly shows your intention and improves code readability. Let's now talk about LockModeType.optimistic. This lock mode is used when you want to prevent conflicts in a multi-user environment without blocking the database rows. Here's how it works. JPA adds a special version field, usually annotated with that version, to the entity. When someone updates the record, JPA checks the version, and if someone else has already changed it in the meantime, it throws an error. This way, two users can read the same data, but only the one who saves first wins. The second one will get a version mismatch error, avoiding accidental overwrites. It's perfect for web apps where you want concurrency control without locking the database row. Now let's look at LockModeType.optimistic_force_increment. It works just like optimistic locking. It still checks the version field to prevent conflicts. But there's one big difference. It forces the version to increment, even if you didn't make any actual changes to the entity. Why is that useful? Imagine you just want to signal that someone accessed or reserved the record, even if they didn't update any field. This lock mode tells JPA, hey, bump the version anyway, I want others to know something happened to this row. So it's a great choice when you need both optimistic locking and a version update for coordination between users or services. Alright, let's talk about lock mode type. Pessimistic_read. This lock mode is used when you want to read data safely, meaning no one else should be able to write or update that row while you're reading it. Think of it like saying, I just want to read this data, but please don't let anyone change it until I'm done. It's especially useful when your application needs consistent read data in high concurrency environments, like financial apps where even small updates can't be missed. Just keep in mind, it does lock the row at the database level, so if overused, it can slow things down or cause contention. Now let's explore lock mode type. Pessimistic_write. This is one of the most strict lock modes. When you use it, JPA tells the database, lock this row right now, no one else can read or write it until I'm done. It's mainly used when you're about to update or delete a record, and you want to make absolutely sure that no other transaction can touch it at the same time. For example, if two users are trying to update the same employee's salary, this lock makes sure that only one update goes through at a time, avoiding conflicts and data corruption. Just remember, because it blocks other reads and writes, it should be used carefully, especially in high-traffic systems. Overuse can lead to deadlocks or performance issues. Finally, let's understand lock mode type. Pessimistic_force_increment. It works just like pessimistic_write. It locks the database row, blocking other transactions from reading or writing it. But here's the twist. Along with locking, it also forces the version of the entity to increment, even if you didn't change anything in the record. So you're telling JPA, lock this row now, don't let anyone else touch it, and also bump the version, even if I didn't modify the data. This is really helpful when you want to track access or activity on a record, not just changes. For example, if one service is processing a record and you want others to know it's being worked on, this lock mode does the job perfectly. It gives you strong control plus version update, but just like other pessimistic locks, use it wisely to avoid performance issues. Let's wrap up with lock mode type. None. As the name suggests, this means no locking at all. When you use this, JPA just runs the query without applying any lock on the entity. So other transactions can read, write, or update the same record at the same time. This is useful when you don't care about concurrency control and just want to read data quickly without worrying about conflicts. But be careful. If multiple users are updating the same record and you're not using any lock, you could end up with inconsistent or overwritten data. So none is fine when you only need simple read-only access, but not when consistency is critical. Alright, now we're going to replicate that for update behavior from JDBC in JPA. To do this, we'll use pessimistic locking, specifically, lock mode type. Pessimistic_write. When you apply pessimistic_write, JPA tells the database to lock the row for writing, so no other transaction can read or modify it until our update completes. Okay, now that our query is locked, let's execute it to fetch the employee. Call getSingleResult method to retrieve the record. Quick heads up, getSingleResult can throw a few different exceptions, like non-unique result exception when more than one record comes back, or pessimistic lock exception if the lock can't be acquired. But to keep things simple, we'll only handle no result exception, which fires when no matching employee is found. By catching this, we can return an empty optional. Finally, let's return our result. Just a reminder, our find by employee ID for update method is called from within update employee. Since we're applying a lock with lock mode type .pessimistic_right. This code must run inside a transaction to ensure the lock is applied correctly. See, our update employee method is already annotated with a transactional, which means everything inside it, including our locking query, runs within a single transaction. This ensures the lock is acquired at the start and held until the transaction completes, giving us safe, consistent updates. Alright, we've added our locking logic in find by employee ID for update. Now, how can we verify it actually works? For a quick test, let's simulate a long-running operation by inserting a thread.sleep, say for 60 to 120 seconds, right after we acquire the lock. Now let's do exactly what I'm doing on screen. Okay, start the application. Alright, let's switch over to dbeaver, the SQL client. Here, we're going to lock the employee record with ID 24 via our API call. Once the lock is acquired, I'll run the same update statement you see on my screen for employee ID 24. You'll notice that this second update call will wait until the lock is released, proving our pessimistic lock is working perfectly. Now let's switch to Postman and call our update API. You'll see the request goes through, but the record doesn't change. That's expected, because right now we've only implemented the locking logic, not the actual update. Oops, we just hit a could not resolve entity employee error. Here's why. JPQL is case sensitive and matches your Java class names exactly. I typed employee in lowercase, but our entity class is named employee with an uppercase E. No worries, let me update the query too. Restart the application. Hit the API again. Great! Our API thread is now blocked waiting for the lock. Let's switch over to dbeaver and execute the update SQL for employee ID 24. See how that second update is hanging and not completing. Let's cancel it now. Check the IntelliJ console. You'll notice that JPA automatically appended for update to our SQL query, exactly what enforces the pessimistic lock. This proves our locking logic is firing correctly. Alright, now let's implement the same locking mechanism using Criteria API. If you remember from our previous video, we already learned how to write criteria queries, so this will feel familiar. Okay. First, we'll create a criteria builder from the entity manager. Next, we'll create a criteria query. Then, we define the root. This tells the query what entity we're working with. OK. Next, select all column using select method of criteria query. After that, we add a where clause to filter by employee ID. OK. Now let's execute our criteria query. Just like we did with JPQL, where we used create query, and then set the lock, we're going to do the same thing here. Alright. Let's restart the application now so all our changes take effect. Hit the API again, just like before. Oops. I just ran into an error. I had forgotten to remove the setParameter method. Remember, in JPQL we use named parameters like employee ID, so we need setParameter to bind values. But in the criteria API, we don't use named parameters. Restart the server again. Hit the API. OK, now let's run the update query in dbeaver. See how it's stuck waiting? That means the row is locked by our API call. Now, check the IntelliJ console logs. You'll notice the same query is running again from the Entity Manager, confirming our lock is active and working perfectly. See, when we want to find an entity by its primary key, we usually use the find method of Entity Manager, which handles everything internally. Similarly, there's a method where we can pass the lock type along with the primary key to get the entity with a lock. Alright, see my screen. The Entity Manager gives us a very handy method that takes three things: the entity class, the primary key, and the lock mode. Also notice this, when we use the find method with a lock mode, JPA not only fetches the record and applies the lock, but it also handles SQL exceptions under the hood for us. That means we don't have to manually catch common issues like missing rows or lock timeouts. JPA wraps those nicely in its own exception types. Alright, now let's call the find method from Entity Manager. We'll pass three things here. First, the entity class, which is employee.class. Second, the primary key value. And third, the lock mode, like lock mode type.pessimistic_right. And it's done. Let's restart the application. And hit the API again. OK, now let's run the update query in dbeaver for the same employee ID. See? It gets stuck. That's because our API has already locked that row using entitymanager.find with pessimistic_right. And now look at the IntelliJ console. The same SQL query is printed again, and this time it includes the for update clause automatically added by JPA. This confirms that pessimistic locking is working perfectly behind the scenes. Alright, quick summary. In this video, we explored how to apply pessimistic locking in JPA using 3 approaches: JPQL, Criteria API, and Entity Manager.find with a lock mode. And we saw how JPA translates these into for update SQL queries under the hood, helping us lock the row safely during updates. In the next video, we'll implement the actual update method and see how everything comes together. If you learned something new, don't forget to like, subscribe to the channel, and hit the notification bell so you don't miss the next part. Thanks for watching, and see you in the next video.